friends, let's rapid revise the quicksort algorithm using animation and learn the basics behind the quicksort algorithm. First of all, quicksort algorithm is one algorithm used to sort a sequence of numbers. One characteristic of quicksort is that it involves fewer comparisons and swap than other algorithms. Okay, so it's able to sort quickly in many cases. Let's take a look at the algorithm in action. The first operation targets the entire sequence of numbers. A number is chosen as a reference for sorting, okay, and this number is called pivot. The pivot is normally a number chosen at random. हम कोई भी number को pivot ले सकते हैं. Here for convenience the rightmost number will be chosen as pivot element. Okay. A marker will be placed on the pivot for easy reference. There will be 3 markers. First for the pivot element, second a left marker that will point to the leftmost number, and a right marker that will place on the rightmost number. Okay. And the quicksort algorithm uses these markers to repeatedly perform rounds of operations recursively. Okay. The left marker will now move to right. Okay, let's discuss the logic behind the quicksort algorithm. Okay. Okay, first of all, we have to discuss the logic, and it should be that when quicksort APQ is called, okay, what will happen is that first of all, first case, if P equals Q, here what is here? A is the array, P is the first marker, and Q is the last marker. Okay, suppose we have got an array of random numbers, that is 50, 20, 40, 30. Here, in this case, our array is A, first marker is P, last marker is Q, and suppose we are taking pivot element as 50 only, so we are pivot marker will be I. Okay, pivot will be pointing to I. So what we'll do is that first case is that when the list contains only single element, that is suppose 60, so it will return the number itself. Okay, then return AP. AP means the single element. Suppose it is a single element, so P would be that, Q is that only, and I is also pointing to 60 only. So A of P will be 60 only. If the single element array is there, then it will simply return the that element only. Okay. Now second case is that otherwise we'll call the partition algorithm. Okay. Partition algorithm will be applied. So APQ only. So what happens in this partition algorithm? Make it full screen. So what happens in partition algorithm is that there is first condition for condition, while condition is that while j is less than equal to q. What do we mean by that? While j is less than equal to q, first of all, initialization of pointers will be like p, I and q here, and also we can say initialize j to I minus I plus 1. Okay, so we are making j as I plus 1 here. This is the initializing condition. These are the, okay, and 50, 20, 40 and 30. So initialized condition is that P will point to the first element, Q will point to the last element, I will point to the pivot element. For here, for the sake of simplicity, we are taking the first element as a pivot element, so I is pointing to the first element, and J will always point to I plus 1. Okay, so we are taking here I plus 1. So while the condition is that while J is less than equal to Q, means J has to traverse the whole list, and it will execute n minus 1 times. Okay, and if when it comes here, it will go out of the loop. Okay, so what we'll do if j is less than equal to q, now what, j will compare the value of pivot with every element. J will compare value, so that is pivot element is what, 50 is the pivot element. Okay, so what will happen is that j will compare every element with the pivot element. Okay, that is 20, 40 and 30. So whatever, by default 20 must come to the numbers to the right of the pivot element must be greater than or equal to that pivot element. Okay, so the condition is that if the element to the right is there is greater than the pivot element, then it's okay and fine, and j value will be incremented. But if it is not so, then something must happen, and what something must happen is shown here. So we can say that if the element here, we can say that if a of j is greater than equal to a of p, then it's okay. It's okay and fine, and increment the value of j. Okay, here it's else. Otherwise, if the right element is less than the pivot element, so it's not okay. It's not okay. Then so the value of I is incremented. The value of I is incremented further, and the value of I and j will be swapped. Okay, so I plus plus is there, and we will swap the values of ai and aj. Okay, like this it will happen, and it will happen again and again until j value becomes greater than q. Okay, this is the basic idea and the logic behind the quicksort algorithm. Okay, so let's execute it on the list, on the array we have got. So 50, 20, 40, 30. Suppose j is less than equal to q. If aj is greater than, here what happens is that after swapping the element is 20 itself, so will it will remain there only. Then then again we'll increment here also, j will increment. After that j will also increment. Okay, so we'll increment j will come here, and again j will be compared. It is less than equal to q, so it will enter here. aj, that is 40, is greater than equal to p pivot element, so it's not okay. Matlab it's okay because 40 is less, it's not okay. So what will happen is that it should increment the value of I. Then again what will happen is that swapping will occur because of this statement, and again j value will be incremented. Okay, now what will happen, then it will again come here, j now equals to q. So again the loop will execute. If it will check again, is 30 greater than 50? No, so it will go to the else part. Then it's not okay, then I value will be incremented again. I will be pointing to here and swap ai and aj. Again the values are swapped. Okay, so since 30 is the only ai and aj, that's why 30 remains here only. Then also j value will be incremented, and j will point to here. Okay, now again we'll check the condition, and j becomes greater than q, so it comes out of the loop. Okay, comes out of the loop. Then what will happen, let's discuss. Okay, j will come out of the loop, and when p exceeds q, then value of I and p are swapped. Okay, so value of I and p are swapped, that is swap ai and AP. Okay, so what will happen is that AI and AP, let's mark them. AP is 50 and AI is 30. So what will happen is that both the values will swap and we'll get the list further as what? 30, 20, 40 and 50. Okay, we'll get that list further as like that. 30, 20, 40 and 50. Okay, then what will happen? It will return the value of I. What is the value of I? I means after partition algorithm, I gives the correct position of the pivot element. That is, the pivot element has now come to its correct position. That means the elements to the left of the pivot element is less than 50 and elements to the right of the pivot element is greater than equal to 50. So pivot elements goes to the right position and the number will return the value as 3. Okay, it will return the correct position. Now what happens? This will place the pivot in its right position and the position will be returned. That is, what will happen is, values less than pivot forms one sublist and values greater than equal to pivot forms another sublist. And again, and this is the end of the partition algorithm. Okay, this is the end of the partition algorithm. And what will happen is that again this pivot is now sorted, but this will happen again and again, and the partition algorithm will be called recursively. Okay, so again we'll call the quicksort on the other sublist. That is, we have got the two sublists here, that is value less than pivot sublist 1 and this is sublist 2. So further we'll proceed by applying quicksort on the sublist 1 and then by applying the quicksort on the sublist 2. Okay, so what will be the algorithm here? Statement will be quicksort, apply quicksort on values on the array A1. Suppose we name it as A1 and this is A2 array, and will be A1 and the starting element will be P, and suppose its position is I, and the position to the left will be I minus 1, position to the right will be I plus 1, and this last element is Q only, so it's like that. So we'll call what? P to I minus 1, and secondly we'll call quicksort A2 from I plus 1 to Q. Okay, this is the further calling of quicksort. Okay, and at the end it will return the sorted array. Okay, so it will return what? Return sorted array. And this is the end of the logic of the quicksort algorithm. So simple is that. So let's let's study with the help of example in the next lecture. Okay, thank you.